Okay, today we're going to talk about surface area and volume, specifically of prisms and pyramids. But first we need to know the definition of a polyhedra. A polyhedra is a solid whose faces are flat. Their faces are polygons. The lines where these faces intersect are called edges. A specific type of polyhedra we're going to look at today is a prism. Prisms specifically have two parallel faces with parallel edges connecting corresponding vertices of the two parallel faces. So here's an example of a pentagonal prism, a rectangular prism, and a triangular prism. And notice how the bases are the same. Okay, here's an example of a polyhedra in everyday life. You have both pictures on your notes. A soccer ball where you have faces of pentagons, and dice where you have faces of squares. Okay. Parts of the prism include their bases and the lateral faces. Okay, the bases are the two parallel and congruent faces. It is important to notice that word congruent. The lateral edges are the parallel edges joining the vertices of the bases. And the lateral faces are the faces of the prism that are not the bases. So the faces of the prism that are not the bases. How to draw a prism. Start with your base. Draw a second base that is congruent. And then connect the vertices. And there's your rectangular prism. Okay. Two important things to know. Lateral surface area. You should have a space for the definition of this on your note sheet. Lateral surface area is the sum of the areas of the lateral faces only, not including the bases. The total surface area is the lateral area of the prism plus the area of the two bases as well. Okay, so again, the total surface area is the sum of the lateral area and the area of the two bases. Okay. Specifically for prism only, the lateral area is the perimeter of the base times the height of the prism. Okay, so it's not the height of the base, it's the height of the prism. Specifically, here you see a red triangle, so you take the perimeter of the base and you multiply it by the height of the prism. Think about other ways you could also find the lateral area of this prism. But to be consistent with all prisms, again, it's the perimeter of the base times the height of the prism. The surface area, or the total surface area, is the lateral area where you take the perimeter of the base times the height and you add twice the area of each base. Right prisms. A right prism is a prism whose lateral edges are perpendicular to the bases. A prism whose lateral edges are perpendicular to the bases. A regular prism is a right prism whose bases are regular polygons. So know that in a prism, the bases are always congruent to each other, but they're not always regular. Okay, so a regular prism is a right prism. So the lateral edges are not only perpendicular to the bases, your bases are regular polygons. Okay. So this is an important note to make. The base of a right triangular prism is not necessarily a right triangle. It just means that the lateral edges create right angles with the base themselves. Okay. This next part is optional. Okay, so you can close the video or you can continue and try some applications with me. So we're going to go to some applications of this, okay? And we're going to use the formulas that we talked about. So specifically when you're dealing with a rectangular prism, your lateral area may come out differently than others, depending on what face you choose as the lateral face, okay? So you're given that this is a right rectangular prism. The length is 15 inches, the width is 5 inches, and the height is the 10 inches. So what we're going to do is we're going to pick this specific face right here, okay? And we're going to count these as our lateral faces. Okay. So that means that in red, we're going to have these as our bases, okay? And that specifically would be your width times your length. So our length was 15, and our width was 5. Okay. So when we're finding the actual lateral area, again, we're going to be taking the perimeter of the base times the height of the prism. So if we're using the red rectangle as the base, then we're going to take 15 times 2, and we'll add it to 5 times 2. There's our perimeter of our base, and then we're going to multiply it by the height. Now, we're taking the height of the prism, and the height of the prism is 10. So again, the perimeter is 40, the height is 10. So we have a lateral area of 400 square inches. To find the total surface area, we take the lateral area and we add to twice the area of the bases. Okay. So we're taking 400 and we're adding twice 15 times 5. So that's 400 plus 150. So we have a total surface area of 550 square inches. All right, let's try another one. Okay, here we're dealing with a hexagonal prism. Okay, it says that it's regular, and we're finding the surface area. It has a base edge of 5, okay, which means the base of the hexagon is 5, and a height of 10. That's the height of the prism. Okay. All right, so to find the lateral, in order to find the surface area, we need to find the lateral area, because again, it's the lateral area plus twice the area of the bases. Okay. The lateral area specifically is the perimeter of the base times the height of the prism. So the perimeter of the base is just 5 times 6, because we have 6 sides. Each side is 5. And the height of the prism we were told were 10. Was 10. So our lateral area is 300 square centimeters. And then we're going to add it to twice the area of the base. Now we've been doing this for the past few weeks. So we need to find the apothem. If the entire side is 5, then the apothem splits it into 5 halves. We've talked about that the interior angle of a regular hexagon is 120. So when you draw a radius, it splits it into 60-degree angles. So we have a 30, 60, 90. So our apothem is 5 halves root 3. So we do twice half the apothem times the perimeter, which we just talked about was 30. So that comes out to 300 plus 75 root 3 square centimeters. Okay, so that's a few applications of the surface area of the prism. We'll do more tomorrow in class. Now you need to go back and click on the video for 12.2.